Celiac disease prevalence has increased fivefold in the United States over the past 50 years, not because of better diagnosis, but because of actual increased incidence. Rubio Tapia et al.'s 2009 gastroenterology study used stored blood samples from the 1950s to confirm this finding directly. Americans today are 5 times more likely to have celiac disease than their counterparts from the same geographic region 50 years ago. Something has changed, and the research points to multiple converging factors: agricultural modifications to wheat protein composition, increased gluten concentration in modern products, and gut microbiome changes that reduce tolerance. Rubio Tapia et al. Demonstrated the incidence increase using a uniquely powerful methodology, measuring celiac antibodies in archived blood samples from 9,133 men collected in 1950 versus current samples from the same Mayo Clinic region. The fivefold increase could not be explained by genetic change. The time frame is too short. Environmental factors, including changes in wheat protein composition and gut microbiome alterations, are the most plausible explanations. This video draws from 5 peer-reviewed studies across gastroenterology, Archives of Internal Medicine, Annals of Applied Biology, Plant Biotechnology Journal, and Autoimmunity reviews, covering celiac prevalence trends, wheat protein composition changes, and gut permeability factors. The debate about gluten harm has been polarized between dismissal, gluten sensitivity is a fad, and extremism, all gluten is toxic. The peer-reviewed reality sits in neither camp. Fasano's population-level research established that celiac disease, an autoimmune reaction to gluten, affects approximately 1 in 100 Americans, with 80 to 90% undiagnosed. Non-celiac gluten sensitivity is a separate, real entity with its own research base. The question is not whether gluten is harmful, it is, to whom, at what exposure level, and why is that population expanding? Modern wheat varieties bred for yield, gluten strength, and baking performance have undergone substantial protein composition changes. Sherry's Annals of Applied Biology Analysis documented that modern high-yielding wheat cultivars contain significantly more gliadin proteins, the immunogenic fraction responsible for celiac and gluten sensitivity reactions, than traditional heritage varieties. Modern wheat can contain 50 to 100% more gliadin than wheat grown in the 1950s. Beyond celiac disease and wheat protein changes, Lerner and Mathias identified a third mechanism: industrial food additives, specifically microbial transglutaminase, used as a gluten glue in processed foods, carboxymethylcellulose, and other emulsifiers, increase intestinal permeability, allowing gliadin fragments to access the immune system in individuals who might otherwise remain tolerant. Fasano et al.'s 2003 Archives of Internal Medicine study remains the foundational American celiac disease prevalence study, establishing the 1 in 133 population figure through serological screening of 13,145 subjects. The study's critical finding was that 80 to 90% of celiac patients were undiagnosed, with false IBS diagnoses being the most common misidentification. The mortality consequence of undiagnosed celiac disease extends well beyond GI symptoms. Rubio Tapia's study showed that undiagnosed celiac disease, defined by elevated tissue transglutaminase antibodies, was associated with a 4-fold higher all-cause mortality over 45 years of follow-up compared to seronegative individuals. This is not a quality-of-life issue, it is a survival issue. The factors driving the 5-fold increase in celiac disease prevalence can be ranked by their evidence base and estimated relative contribution to the rising incidence. Celiac disease and non-celiac gluten sensitivity develop through distinct but related immune pathways, both involving gliadin interaction with the intestinal immune system, but with different HLA genetic requirements and different degrees of villus damage. The evidence-based framework for managing gluten exposure begins with appropriate diagnostic testing rather than empirical elimination, because undiagnosed celiac disease requires lifelong strict avoidance that is different from dietary preference-based reduction. The timeline for recovery from gluten-related intestinal damage depends on the diagnosis. Celiac disease requires months to years for full villus recovery, while non-celiac gluten sensitivity typically responds faster. Managing gluten-related conditions requires a systematic approach covering testing, elimination, cross-contamination avoidance, and nutritional support during recovery. Gluten management is highly individualized based on diagnosis type, symptom severity, and lifestyle constraints. These adjustments match the protocol to each clinical situation. The increase in gluten-related pathology is real, peer-reviewed, and multifactorial. Here is what the science shows. The evidence is clear. The mechanisms are understood. And the steps to identify and manage gluten-related conditions are within reach, for anyone who tests first rather than guessing. Follow MedBrief Today for more science-backed health insights, explained clearly.